In this video, I'm assuming that if I hand you a rational function, you already know how to find the x-intercept, y-intercept, vertical asymptote, horizontal asymptote, holes, and domain. This video is just about how to put that all together. If you don't know how to find those things, look through my channel, find out how to find those things. Okay, first thing that I'm going to find are the things that I don't need to factor for. There's two of those, horizontal asymptote and y-intercept I don't actually need to factor for. Horizontal asymptote, I think about Bobo-Botten eats DC. In this case, the degree on top is 1, degree on bottom is 1. So this is a eats DC. Exponents are the same, divide coefficients. For my horizontal asymptote, I'm going to have a horizontal line, so y equals, and I'm going to divide coefficients. I'm going to divide the leading coefficient 2 by the leading coefficient 1. I get 2 over 1 equals 2. My horizontal asymptote is y equals 2. So on my graph, I'm just going to put a line, a horizontal line, at y equals 2. I put it dotted because it's not actually part of the graph. It's just a guide to help me graph it. That's horizontal asymptote, y equals 2. The other thing I can do without actually doing any factoring is I can find the y-intercept. To find y-intercept, I plug in a 0 for x. I get y equals 2, 0, minus 4 over 0 minus 3. That's negative 4 over negative 3, 4/3. My y-intercept apparently is the point 0, 4/3. So if this line was y equals 2, 4/3 is somewhere between 1 and 2. Here's 1. 4/3 must be here. That'll be my y-intercept. Next, I do some factoring. I factor the top and the bottom, the numerator and the denominator, as much as I can. The numerator, I have a GCF. The denominator, I do not. Once it's factored, I'm ready to think about domain. Domain, remember, comes from the excluded values. I look at this denominator, and I say, what are the zeros my denominator? Well, 3 is. 3 is an excluded value. My domain is everything except the excluded values. In this case, 3. So my domain is the set of all x's where x is not equal to 3. After I've done that, I can do some simplifying. In this case, there's nothing to simplify. There's no factor on top and bottom. In general, I would simplify. After I simplify, I look at the numerator to see what my x-intercepts are. The zeros of my numerator are going to be my x-intercepts. In this case, the only 0 of the numerator, the only thing that makes this come out to 0 is 2. The only x-intercept I'm going to have, therefore, will be 2, 0. Well, x-intercepts always have a y value of 0. So on my x-axis, let's say this is 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. I'm going to have an x-intercept at 2. I factored, I simplified. The zeros of the numerator were my x-intercepts. Zeros of the denominator I already found, right? That was my domain. But the zeros of the denominator that are still sticking around, the things that are still excluded values, those are my vertical asymptotes. In this case, 3. I have a vertical asymptote of 3. Vertical, so it's x equals. I'm going to do a vertical line dotted at x equals 3. So just to be clear, 3 was an excluded value before factoring, and 3 was an excluded value, not before factoring, 3 was an excluded value before canceling, and 3 was an excluded value after canceling. That makes 3 a vertical asymptote. The things that were excluded values before canceling, but are no longer after canceling, those are holes. Here, nothing canceled, so there were no excluded values that got eliminated. So in this case, there are going to be no holes. So we have an x-intercept, y-intercept, vertical asymptote, horizontal, holes, domain, range, and behavior I'll do in a second. I'm ready to start sketching a graph. From the way that these graphs look, I know that the asymptotes are things that I get really close to. So I'm going to have to do something like this. If I hit my y-intercept and x-intercept, I know that after I hit those, I have to just get really, really close to the horizontal asymptote and the vertical asymptote. And then, to the right of the vertical asymptote, there's either a piece here or there's a piece here I just need to make a little table or try a point to figure out which one it is. If this is 1, 2, 3, 4, I'm going to plug in x equals 4. When I plug 4 in for x, I get y equals 2 times 4 minus 4, or 4 times 3. I'm just figuring out what point goes with x equals 4. That way I can put it on the graph and get a better sense where the graph is. This is 8 minus 4 over 1, so 4 over 1, which is 4. Apparently the point 4, 4 should be on my graph. So 4 would be here. So my graph, my other piece must be in the top, and I make sure that I get close to the asymptotes. This would be my graph. And you know what? Let's skip range and behavior. We'll do that in class. So this one, if I wanted to sketch a graph of this, first I would do the things that I don't need a factor for. That's horizontal asymptote and y-intercept. Horizontal asymptote, I think both bottom eats DC. I compare the degree of the top and bottom. The degree of the numerator is 2, degree of the denominator is 2. This is an eats DC situation. Exponents are the same, eats, divide coefficients, DC. So I'm going to divide coefficients. My horizontal asymptote will be y equals because it's a horizontal line, and I divide the leading coefficients. 1 divided by 1 is 1. My horizontal asymptote is y equals 1. The other thing I can do before factoring is I can find my y-intercept. If I plug in 0 for x, I get my y-intercept. So I get 0 squared plus 3, 0, plus 2. 0 squared minus 4, 0, minus 5. 2 over negative 5, negative 2/5. My y-intercept is the point 0, and a y value of negative 2/5. That's going to be something like here on the graph. If I'm counting by ones, 1, 2, 3, 4, 1, 2, 3, 4, negative 2/5 is somewhere between 0 and negative 1. Now that I've done the two things I could do without factoring, now I have to move on to factoring. I factor the numerator, and I factor the denominator. My domain comes from the zeros before I simplify, so my domain is going to be all of the x's except for 5 and negative 1. All of the x's except for the excluded values, the zeros of the denominator. So all of the x's except for 5 and negative 1. Set of all x's such that x is not 5, and also x is not negative 1. Then I can simplify. Once I do domain, I can simplify. I can cancel out an x plus 1. And I'm left with x plus 2 over x minus 5. One of my excluded values canceled out, one of them didn't. The one that didn't is x equals 5. That means that's going to be a vertical asymptote. After I simplify the things that are still zeros of the denominator, those are my vertical asymptotes. So at 1, 2, 3, 4, 5, I'm going to have a dotted vertical line. That's my vertical asymptote. The things that did cancel out, in this case that negative 1, that will be a hole. Negative 1 comma something is going to be a hole. The something comes from plugging negative 1 into the simplified. So if I plug negative 1 into x plus 2 over x minus 5, I get 1 over negative 6, so negative 1/6. I have a hole at the point negative 1, negative 1/6. So on my graph, I go to negative 1, negative 1/6, and I draw not a point, but a hole. I still have x-intercept left. X-intercept comes from the zeros of the numerator after I simplify. X plus 2, that's only equal to 0 when x is negative 2. My x-intercept is going to be negative 2 for x, comma 0 for y. That's on the x-axis. So I go to negative 2 on the x-axis. I draw my x-intercept. Now I have all the pieces except for range and then behavior. I connect them all, and I make sure to get nice and close to my asymptotes. to the right of the vertical asymptote. I could be up here, I could be down here. To decide which one, I'm going to have to plug in a point. If I plug in a point past 1, 2, 3, 4, 5, if I plug in a point past 5, I get, let's say I plug in 6. Plug in 6. I can plug it into the simplified version. I don't need to plug into unsimplified, so I'll plug it into x plus 2 over x minus 5. X plus 2 over x minus 5, 8 over 1. Apparently the point 6, 8 is on my graph. I don't even have room for that. 1, 2, 3, 4, 5, 6, 7, 8. My point's going to be 6, comma 8 is going to be all the way up here. So I make sure that I draw a graph that comes from up here and goes all the way down here and eventually approaches the horizontal asymptote. We'll do one more. First, I think about the things I could do without factoring. That's horizontal asymptote and y-intercept. My horizontal asymptote comes from Bobo-Bodden eats DC. In this case, the degree on top is 0. The degree on bottom is 2. Bigger on bottom, Bobo. The last O, bigger on bottom, B-O-B. The last O stands for y equals 0. My horizontal asymptote is y equals 0. It's bigger on bottom, so y equals 0. My horizontal asymptote. Next, I think about the other thing I can do without factoring, y-intercept. If I plug in a 0 for x, I get 5 over 0 squared plus 1, 5 over 1. Apparently, my y-intercept is 0, 5. 1, 2, 3, 4, 5. My y-intercept is 0, 5. Next, I do some factoring. And in this case, nothing factors. So I go and I think, okay, well, nothing factors, so my excluded values should still be in my domain. Excluded values come from what makes the denominator 0, what makes x squared plus 1 0. Well, that happens if x squared is equal to negative 1, which means x is plus or minus I, because I take a square root. X can't be I. There's no I on my x-axis, so I ignore that. The domain is all real numbers. It can't be I, but who cares? It's not a real number. The x could apparently be any real number. So I say the set of x's where x is in the real numbers. The fact that the domain is all real numbers tells me something about the vertical asymptote and the holes. Because remember, vertical asymptote comes from excluded values that don't cancel out. There were no excluded values. Nothing canceled or didn't cancel. There were no excluded values. So there's no vertical asymptote. Holes come from excluded values that did cancel out. There were no excluded values, so obviously none canceled out, so there's no holes. X-intercepts come from after factoring and canceling. There's nothing to factor, there's nothing to cancel. Looking then at the zeros of the numerator, looking at what makes 5 equal to 0. Nothing's going to make 5 equal to 0. They are different numbers. No x value is going to change that. So there's no x-intercept. Now I have all the pieces I need. I'm just going to sketch a graph that gets close to this horizontal asymptote, but must also hit here, but also gets close to the horizontal asymptote. All right, this is part 1. I'll do some more. This is good for now.